So they say study the two transverse waves. We have P and Q, and show us the key. P is solid and Q is dashed. So here we have our position versus time graph. And if you can remember, do you have your notes? Do you have those notes near you?
Yes.
Okay, so let's just say from the zero line or the equilibrium to A. So like, what can you tell me about this line here, from here to here? What do we call this line? Or what do we call this distance? Just from here to here.
The wavelength.
It's gonna be our amplitude.
Uh,
So the amplitude is gonna start at the equilibrium, which is mostly gonna be a zero position, and it's gonna go all the way up to the highest point on your wave. So from 0 to 15, that's gonna be our amplitude. But from B to D, that's where we have our wavelength. You see? So remember, our amplitude is on the Y, and our wavelength is gonna be on the X. Can you just keep that in mind, that amplitude is gonna be vertical and wavelength is gonna be horizontal. Sorry about that. So we also have this time from 0 till the end of this wave, which is from 0 to 1.5. Can you try to remember what this time represents? The amount of time it takes for one wave to be completed. Sorry.
are you asking me?
Yeah, sorry, I'm asking you, sorry.
Excuse me, what are you asking me again?
Um from the start of this wave, no? You can see that this is where the
Yes.
wave starts, and this is where the wave ends, and this is
Okay.
where another one starts, and this is where another one ends, no? So
Yes.
there's these time points. Here you have 1.5, and here you have 3.0. What does this time, the 1.5 seconds represent?
Um, is it the first,
Now just
the
check.
period?
Sorry.
The period.
Yeah, that's correct. It's gonna be the period. So you see, at least like you have some parts of it. You have some parts of it figured out. So this is gonna be our period. This is our amplitude. And I don't think, and from here, if you are able to like identify a wave from here to here, it's gonna be one wave. So the distance covered by one wave, what do we call that? Or let's say the distance of one wave or the length of one wave. I think saying length is much better. So can you tell me what we call the length of one wave?
Length.
Sorry?
Must I calculate or something?
Nah, you don't have to calculate. You just tell me, okay, so you remember we have our amplitude, we have our frequency, we have our period, we have our wavelength. Those are the only four things that we're gonna focus on the speed. So we're gonna focus on these five things, right?
Yes.
So I just want you to tell me, I'm just gonna give you the definitions and you're just gonna try to match them with the words, né?
Okay.
So I think that would be good. We should try that right now, né?
Okay.
Yeah. So what we're gonna try, I'm just gonna write down the words here, add text. So we're gonna say frequency. We're gonna have amplitude. We're gonna have wavelength. And period. And then like we're also gonna have the speed. So what I'm gonna tell you is that these things are basically self-explanatory. So right now, what we're gonna do is that I'm gonna give you a definition, and you can just choose from these five words which one it is, no? Is that fine?
Yes.
Okay, so I remember you were able to define period, so we're gonna skip period. So we're gonna say the length of one wave. So what do you think the length of one wave is called? Are you still there?
Yes, I'm just quickly thinking.
Okay, sorry.
Is it wavelength?
You see, like it's not, you see, exactly, yeah, it is wavelength, but if you look into it, like it just explains itself. It's the length of one wave, so it's gonna be wavelength, right?
Yeah.
And then I can't say the speed of the wave. So let's say the time it takes for one wave to be completed or to complete.
Is that period?
Yeah, that's gonna be the period. And the distance from the equilibrium to the minimum or maximum point on the wave.
Amplitude.
Exactly. And then we're gonna have the distance covered by the wave over a period of time. So when I say it like this, look at it like this. You're gonna have a distance that is being traveled at a certain within a certain period of time. So what do you think that is? Let's say let's say you're in a car and it travels 10 kilometers in 5 minutes. So what do you call that?
Is that speed?
Exactly, speed. I don't know if like my analogy was correct, but at least I think you get the idea. So the last one is the number of waves passing through one point in 1 second.
Frequency.
Okay. So I suggest like you try to remember all these definitions, and then after you remember all of them, you can try to apply them on like the actual wave. So here, this is going to be the distance of one wave or the length of one wave. So this is going to be a wavelength. And this time here is the amount of time it takes for one wave to be finished. So this is going to be our period. So now we can go on to our questions. So question one, they say 6.1, they say write down one difference and one similarity between wave P and wave Q. So if we look at wave P and wave Q, so you know the solid one is P and the dashed one is Q. What can you say is different? So this is the amplitude. What can you say is different between the two waves?
Wave A is up and the other wave is down.
Yeah, like that is correct, but since we're speaking in terms of like scientifically, we can't just say it's up and the other one is down. So in accordance to these these five these five factors that we're going to be focusing on, which one is different between the two waves and which one is similar? Sorry, let's just focus on a different one right now. So look at the wave, and let me just try to copy this elsewhere. Uh, uh, let me just try to put it on the other page. Oh, yeah, I'm sorry. Let me just put it here. It won't go down, so let's just say we have our frequency, we have our period, we have our speed, we have our wavelength. So from looking at this, from looking at these two waves here, which ones do you think is different? Because we have our amplitude here, we have our period here, and we have our wavelength here. So which one do you think is different between the two? You already mentioned that this one is up and this one is down. So which um which factor are we focusing on when you say this one is up here and this one is down here?
Is it the amplitude?
Yes, we're gonna that's gonna be the amplitude. So the one that is different, that's gonna be the amplitude, and now we're gonna have to find one which is similar between them. So our amplitude is different. What about our period and wavelength? Are they similar between wave P and Q?
No.
And why do you say so?
Because the numbers, the time it takes to complete a wave is different for each one.
Okay. Can you try to explain that? So like let me try to erase everything. Yeah, let me just try and erase everything. Why? Nah, sorry, it's not erasing, so that's a bummer. Yeah, but anyway, can you try to explain that?
What must I explain?
You said that the periods are different. Sorry, the time it takes to complete the waves is different. Can you tell me why you're saying that? Like just try to put it in words as to why you say like the times are different.
It's different because the wave by A it's positive, but then by the wave B it's in negative.
Oh, okay. I think there you got something wrong, but so let me just try using a different color here. So when you look at it, this is where these are the two ways that we're going to be focusing on. Sorry. Can I just erase this? So we have our wave P, which is the one above, and our wave Q, which is the one below. If you look at it, all these waves, they start here and it's gonna end here, and then a new one starts here and it's gonna end here. So if you look at it, it goes up and down into the negative, and then it goes up again, and in 1.5 seconds. And P also goes up, down into the negative, and up again in 1.5 seconds. So the period of the waves is equal. Do you understand it? Do you understand it? Because a wave is
Yes.
basically when it goes up, down into the negative, and back up. This is a complete wave from here to there. Okay. So that means our periods are equal. And our wavelengths are equal. If you look at it from down here, if the periods are equal, and down here you look at it, this is one complete wave in Q, and this was one complete wave in P. I'll try on Thursday, I'll try to help you identify the complete waves and incomplete waves, and you'll see how you sorry, and you'll see how you identify a complete wave and all that type of stuff. But for now, just know that this is a complete wave, and this is a complete wave. So what's different? What's different between these two waves is going to be the amplitude, and what's similar is the wavelength and the period. I hope you understand that part. But I'm pretty sure do you understand the period part?
Yes.
Okay. So they say for wave pattern P, so we're just gonna look at the solid wave. You have to name 2 points that are out of phase, and they want the amplitude of the wave. So for P, when they say points are in phase, they usually mean that these 2 points are have one wave between them. So if you look at C and A, these 2 points are in phase. And if you look at B and D, these 2 points are in phase because between B and D, there's one full wave. And between A and C, there's one full wave. Do you understand that?
Yes.
Okay, so whenever you hear points that are in phase, just know that there must be one full wave between the 2 points. And we're also, as I said, I'll also help you I'll help you on how to identify full waves, and that's in our next session. But now let's just do this. And I want you to calculate the amplitude of the wave. So here you have we have an amplitude, it's 15, but the problem is that it's in millimeters. So in physics, we're always gonna use our SI units. And the SI unit for distance is always gonna be in meters. So if you get your units and they give you them in like millimeters, in centimeters, you're gonna have to convert them to meters. So here we have 15. We're gonna take that 15 divided by 1,000 to convert it to meters. So we're gonna have, just quickly calculate 15. 0.015 meters. So do you understand so far?
Yes.
Okay. So the next question, they want you to define frequency. Can you define frequency in your own words? Not like in my words, but in your own words, how you understand frequency. Can you try?
It's the amount of waves passing in seconds.
Passing 1 point in 1 second. Just remember that it's one point in 1 second. Okay.
Okay.
Okay. Yeah, please try to remember that. Usually these definitions, they're always gonna be there. So now we're gonna look at wave pattern Q. Sorry, but I'm not using like the pro version of Zoom, so I think it's gonna cut real soon. So how about I